Those of you who work with commercial refrigeration systems, you know that there's a number of ways you can collect these systems into racks. It could be a low temperature rack, a high temperature rack, it could be a rack dedicated to walk-in units or open cases and so forth. And this graphical grid system makes it much easier to configure and assign properties to those refrigeration systems. So this is a new feature, again, in OpenStudio 1.3 to make the configuration of refrigeration system objects much more straightforward. The second new feature we'll talk about today for OpenStudio 1.3 is support for variable refrigerant flow objects. And again, this is essentially supporting the same feature that is available in Energy Plus 8.0 or 8.1 for modeling VFR, variable refrigerant flow systems. OpenStudio supports systems that use different levels of refrigerant, whether it be R22, R410A, carbon dioxide, whatever, and different in the sense that the VRF objects are modeled based on performance curves. And just like in Energy Plus, these performance curves are essentially empirical. They're curve fits off of some performance data provided by manufacturers. So you'll see in the center of this slide is an example of performance curve for an indoor unit. Some manufacturers provide this data in a tabular form, some in a graphical form. At the bottom right is a key document. If we're going to model VRF systems in Energy Plus, the FSEC, Florida Solar Energy Center, published a great document, again, walking through step by step how to create those performance curves for VRF heat pumps in Energy Plus or now in OpenStudio. The objects that we support in OpenStudio, similar to refrigeration, is a VRF system object. Then there's also VRF indoor terminal unit objects. Those will be our indoor units, and also our VRF outdoor units. And then as VRF units are configured, there's essentially one outdoor unit and many indoor units married to that outdoor unit. In addition, OpenStudio supports the modeling of different VRF strategies, such as heat pump units, which those are VRF units that either operating in a cooling mode or a heating mode and then back to cooling and so forth. Or a more complex strategy, which is a heat recovery unit, essentially a three-pipe unit, where the outdoor unit may be operating in one mode, heating or cooling, but the indoor units may be sharing the heat rejection amongst themselves in addition to rejecting heat to the outdoor unit. Again, a direct application or implementation of how VRF in OpenStudio direct the heat rejection for the outdoor unit to either air rejection, air source, water source, or evaporative cooling. And we can also select from a number of different defrost strategies for our outdoor units. And finally, there's an implementation of different priority control types, essentially where the thermostat is located and how the thermostats behave on the indoor units and how they control the outdoor units. So this is a very special object, or set of objects that OpenStudio has taken in. If we go to the next slide, we see that the implementation in the OpenStudio application for VRF is somewhat similar to refrigeration. It is yet again a drag, drop, and configure scenario where there's one outdoor unit and many indoor units, and then each indoor unit has a thermal zone attached to it. So we'll see again more examples of this when we look at the live demo, but it's very flexible. At the bottom right, you see I built an example building that had 5 outdoor units. Each of those outdoor units had either as few as 4 indoor units or as many as 8 connected to them. And again, this is a 30 zone model, something like that. So it makes it very simple once one has the performance curves to configure a model quickly to examine VRF performance, whether that's heat pump or heat recovery or different thermostat control strategies and so on and so forth. The last note I would say about this slide is that we saw earlier the TPEX, Technology Performance Exchange, which is feeding data into the building component library, which then feeds in data to OpenStudio. It is planned that TPEX would feed in VRF performance data. That's in the short-term roadmap here, that we should see sets of VRF performance curves coming through the Technology Performance Exchange database and ported over into the building component library and thus into our OpenStudio models. So that's a very exciting feature that's coming, not available today, but coming. Finally, there is a library that ships with OpenStudio called the HVAC_library.osm file, and it contains a number of default VRF curves to help us, again, start to develop our own curve sets for these objects. Very important that we don't just use default curves when we're modeling VRF systems. These really require individual designs to be created, and then the performance curves based on those designs to be developed. Powerful feature. Going on to the third feature that I'd like to talk about today is the supply and return plenums, or support for modeling those. Essentially in OpenStudio, a supply plenum or a return plenum is just an unconditioned thermal zone. So it's a special type of thermal zone. It has no thermostat. It can have gains such as lights, or maybe, probably not people, but other types of equipment and so forth. But it's simply marked as an unconditioned thermal zone in the object model. And the unique thing about supply and return plenums is they can act again, they do act within the energy balance at the time step, at the simulation time step, as both a heat and mass balance. So they're not meant to represent duct leakage by any stretch of the word, but they are meant to improve the modeling of HVAC systems where we commonly see things like return plenums that are used to collect the return air before it goes back to our air systems and our return fans. You'll see the image at the bottom left here. The color codes describe common plenums. So we have, in this individual air loop, we have a purple or a magenta supply plenum serving two different zones, and we have a sort of a yellow or brownish yellow return plenum serving two different zones. So it's very flexible the way that this was implemented in OpenStudio. Plenums can certainly cross zones, or they could be one-to-one. What is unique about this is the plenums cannot cross systems. So an individual supply return plenum can't serve more than one air loop, essentially. So we'll see again in the demo this, in a few moments how to set this up. It's very graphical. It's drag, drop, and configure, just like the VRF and refrigeration modules were. So there's something unique about the supply plenum and return plenum in the sense that we have to create it, and that means we have to go into the geometry of the form and fabric and actually create the geometry to support plenums. So in OpenStudio, that's actually very easy to do using the SketchUp plugin. We can simply insert zonal spaces like we see on the image at the top left, which would be two return plenums here. And then we would use things like the space type capabilities in OpenStudio to apply properties to that plenum. For example, the plenum would not have any lighting, it wouldn't have any internal gains, and it would have probably a special construction set to represent that interzone surface between the ceiling below and the plenum floor, if you will. So those can be very rapidly created and assigned using the OpenStudio space type properties. And then once we've assigned those, that's where that information will feed our heat balance at the time step. So again, you can see at the bottom right, there's an image where I took a section cut through our model, just confirming that it was modeled correctly. I do have interzone plenums here that serve a thermal zone that happens to cut across the entire floor. And that's very easy to do in SketchUp, and then in the next step in the OpenStudio application to go ahead and assign this space, this plenum space, to a thermal zone and then assign it to an air system. So the next thing I want to talk about here in terms of OpenStudio supported features is support for the ASHRAE Energy Design Guide 50% measures. And this is no small feature. This is actually a very powerful, so let's take a little time to explain this. Many of you might be aware of the printed documents. You'll see them on the right of this slide. They're available for free downloads from ASHRAE, and there's a number of different sectors that are covered, and there's a number of different we'll call them percent savings that are covered. So the two I've highlighted here is the AEDG for K through 12, 50% guide, and also the AEDG small to medium office building 50% guide. So these are new construction guides. They're very large text. They're probably several hundred pages that print out as PDFs, and they carry inside them prescriptive descriptions of measures, ECMs if you will, that if implemented would achieve something on the order of a 50% site energy savings over a code-compliant building. Now these are not just simple measures, these are also measures that depend on of course, what climate zone you're in. So measures that are, say, in a cold climate like envelope measures in Alaska are much more aggressive than they would be in Hawaii. And those are prescriptively described again in the printed documents for the AEDG. What Emerald has done in this release is they've created OpenStudio measures that represent the prescriptive guidance in these documents. And it's not one, it's not two, it's not 5 measures, it's something on the order of 50 measures that have been added to our measures library and the building component library, both for K through 12 and for small to medium office sectors, that are simply drag and drop now. And that's actually a very exciting feature for OpenStudio for a couple reasons. I'll show here again how the measures are intended to work. Essentially, for those of you who don't know what I mean when I talk about a measure is an OpenStudio term. It represents a collection of a Ruby script, essentially a collection of code that contains logic for very easily and, more importantly, very consistently transforming an energy model. And essentially, measures can be applied either inside our OpenStudio application, we call that a sidecar measure, or they can be applied as part of a simulation study, part of an analysis using the parametric analysis tool, or both. And in the center of the slide, you see an example of an interior lighting control measure. And it literally is a drag and drop, and it will automatically change the lighting schedules that are in your model. So these measures prescriptively change whatever they're designed to change to match, again, the prescriptive requirements of the AEDG guides. To support this, there was also a standard taxonomy that was developed so that we could classify these measures. So some, again, are interior lighting, that's a classification. HVAC whole systems, that's a classification. Cooling, heat rejection would be a classification, and so forth. So that we can, again, add these to the building component measures library. We can see very easily where they are, and we can essentially drag, drop, and configure them. Configuring them at this point just means assigning a cost to them. That the performance is prescribed. And now we really need to just prescribe or assign a cost to them, and we can apply them to our model very quickly. Before I move to the next slide, I want to just touch briefly the bottom right, what are known as HVAC whole systems measures. These are can be very elaborate. Essentially, they'll take whatever is in your model, whether you have a 4-pipe fan coil unit or unit ventilator or unit heaters or whatever you have. They rip those systems out and they replace them with new HVAC systems that are, again, prescriptively compliant with the AEDG 50% guides. So that's drag and drop and assign a cost to it. Actually very easy to do. Moving to the next slide, just to think about a couple ways of how this could be used, and there's probably many more, but these are two that I think about. The one on the left is simply that we use OpenStudio. We use the SketchUp plugin to build form and fabric, essentially the envelope. We use the OpenStudio application to build some kind of what we'll call a baseline building. It could be a code-compliant, barely legal building. It could be our building as it is now in a retrofit case. And then you'll see at the bottom right, we use PAT, bottom left, sorry, and we apply the prescriptive AEDG measures as quick as possible. And that would very quickly allow us to start to evaluate what I'll call deep savings, stretch savings over the baseline with very little effort. And that the measures were created in order to give feedback, not in terms of simple payback, but rather in terms of life cycle analysis. So again, the goal here is to try to get this sort of feedback into the stakeholders, back to the design team as quick as possible. So that's one workflow, again, building a baseline model and then slapping on a number of prescriptive AEDG measures onto that baseline model and seeing what you learn from it. The second workflow on the right might be a little different. It's essentially saying, well, start with the model you have and use these measures to create a better model, a better baseline, if you will, a better baseline model. And some of you might be familiar with the term technical potential or something like that, and we say, well, how do we build a technical potential model? Well, one way might be to, again, start with your basic form and fabric of the building, and just add these measures to it. And then your baseline model becomes an AEDG model, essentially. So that's a different workflow. And what's interesting about this workflow on the right is that when you add these measures, these AEDG measures, you can create a new model, essentially a new baseline model. So you don't have, and I'll show you an application, and I'll show you a demonstration of this to probably be more clear. You don't just have a model with a measure attached to it. You're literally changing your model. You're literally altering the model itself. So this can be a very rapid way. For example, I wanted to start a model with some radiant systems involved in it. Well, I would add the AEDG radiant systems measure, and then later I would start to customize things like the set points, the boiler capacities, and so forth that I want for my model. Okay, we're very close to starting the live demo. I just want to show again that these measures, this is probably one of the, in my opinion, one of the coolest features of 1.3, is that these measures are not trivial. Some of them can be very complex, and I just want to show an example here of a daylighting measure package applied. So it's a single measure, single AED measure applied to a K through 12 school. And what did that measure do? If you look here carefully, you can see it actually changed the size of the window. It changed the properties of the window. It did that by window orientation. It added skylights to certain types, certain space types. It left certain space types alone and did not add skylights. It removed windows from certain orientations. And essentially what it does is this instills best practices as they're described in the AEDG guides. And I can't say this enough, it's a drag and drop. So again, starting with a best practices model might change the way that we work if we were to be able to get there easily. And that's what we can do with the support of the AEDG measures. So let's go ahead and move over to the live demo. I'm going to do this in a little bit of a different order because I'd like to set up an AEDG measure run. We'll build a quick model. We'll slap on some measures, and we'll set up a pat run. While that's running in the background, then we'll go ahead and demonstrate the refrigeration objects, VRF, and so on and so forth. We'll see how far we get with the time permitting. Maybe we'll get to here. And I do want to respect everybody's time and end on time. So let's go ahead. I'll just jump over into SketchUp. And I'm just going to build very quickly. I'm going to delete Susan because she often gets in my way. I'll build a very quick model, 100 feet by 60 feet. Okay, and we'll look at that from the top view. And we'll just cut this model up simple enough so it doesn't become too difficult for us to work with. This is going to be a very simple school model. We just need some spaces so we can apply some different space types to these. So good enough, that's okay, and then we'll cut a corridor here. We will erase some things that seem to be in the way. And again, you could do this a number of ways, bringing in sketching on the top of PDFs or what have you, DXFs and so forth. In this case, I have a footprint of a building. I'll go ahead now and select that footprint, and I will extrude it into a building, and I would like to go ahead and create spaces from diagram. Let's make that 12 feet high and 2 stories. That's fine. So I have a number of OpenStudio spaces here now, and what I'd like to do now is to run a routine to make sure that I don't have interior walls and exterior walls butting up against each other properly. So that's a function here in the SketchUp plugin called surface matching. I'll intersect the entire model, and I'll match the entire model. And again, now I have the proper intersection between interior walls. Next thing I'd like to do here quickly to set this model up is to assign some space types. I'll just collect those spaces. I just grab those, and I would like to go to the building component library, which requires me to go here, and I'll get some VCL space types so I can rapidly assign objects. I'm going to make this an old secondary school. And so there we are. So I'll download those space types remotely. Once I download them, I'm going to assign them. I'll just do this very quickly, just to get somewhat of a realistic model so that we can run the AEDG measures on top of it. And it's a small building. It's 100 by 60, but again, it would serve the purpose for today. So you'll see OpenStudio downloading a number of space types from the remote building component library. Almost finished. Done. Okay, so again, I will select some spaces. I will use OpenStudio's tools here for selecting attributes, and I'm going to make those in very old classrooms. Okay, and I'm going to make the bottom, well, let's make those guys also classrooms. And again, one can build their own space types and build their own models for this, their own inheritance objects. We'll leave those as classrooms as well. Let's take this corner here and let's override it and turn it into a, well, I don't know, cafeteria. And let's put an office right here. So we can do that very quickly. Again, assigning that an office. Okay, fair enough. Now we're done. Now I need to realistically add some fenestration here, so we'll just run a script for doing that. Set the window to wall ratio. Something like that is fine. Okay, now we have a model. And since we assign space types to this model actually has full attributes. It has people, it has lighting, it has equipment that is appropriate for a pre-1980 secondary school of that space type that I assigned. We're just going to go ahead now and launch the OpenStudio application. And I can say that's fine. And that should launch the OpenStudio application here momentarily. The next step for us would be able, again, to give it a climate zone because the AEDG measures need to know what climate zone we're in. We're going to go choose 5A. And we need to feed it a weather file. I'm going to feed it Chicago, which is in 5A. And I'll need to feed it a design weather file as well. So let's just make sure this works before we go any further. I'll run the model quickly. All we've done right now is just create what I'll call a seed building. I want a seed building that I know is going to work before I take it into PAT. And boom, we have a good seed building. So okay, that is good. Okay, excellent. We got, just to prove it, we should have some results. Oh, we have no HVAC. We have nothing like that, so we'll very quickly add an HVAC system to this. And again, in the interest of time, I'm going to make it very simple. I'm going to just throw all of our thermal zones. We'll create a simple thermal zone. And we will then attach that thermal zone to an air system by default. I know this is things that, again, you have to do just to get a model to work correctly. And then we'll go over here and we will take our spaces and assign them to that thermal zone. So essentially we're building an HVAC system here. And I have, excuse me, these spaces, again, need to have that thermal zone assigned. So it'll take me just a moment to drop those in, and I'll just one by one assign them. So, okay, moving along, okay, almost done. So, of course, we don't have a service hot water system and all that. That's fine. But now that we have a thermal zone and an HVAC system configured, let's make sure it'll run. And we'll move it over into PAT and we'll add the AEDG measures. Just to make sure again that this is running. Looks good. We've got it running. Okay, great. So now I don't want to save this until the run finishes, so I'm going to wait just a moment for that to finish. In the meantime, I'm going to go ahead and open up PAT, Parametric Analysis Tool, and I'll start a new project, and we'll call that 5.6 demo, AEDG demo, and we'll stick to that in my desktop studio training directory. That's fine. Pat wants us to load a seed model, so we'll go back here and we're just about done with this model. Once again, we know that it runs successfully. We're going to move it over to Pat. Okay, just got it done. And writing some reports out, and okay, we've got some energy use. That's fine, that's good for now. So we'll make sure we know where that model is. It's under, I'm going to drop that in the same directory. It's OpenStudio Training. And we'll call that 5.6 model. Okay, so there we go. And I don't need this anymore. I can, once it's finished saving, I can shut down OpenStudio application. I can go over to Pat, and I can load the seed model. So going back to that directory, OpenStudio training directory, I should see my 5.6 model. I'll open that up as my seed model. And now I'm going to lay some measures on Pat that represent the AEDG measures. So let's just do a few really quickly. We'll get it spawned, and then we'll go demonstrate the other features as well. This is not really meant to be a training on Pat. So see, this is finished. Yep. We'll probably move through this rather quickly. But what we're going to do is I've already went ahead and downloaded the measures from the building component library into my local directory here. You'll see as soon as Pat updates, we'll see a number of measures that are available in the building component library. While we're waiting for Pat to load, we'll go back here, and I will go ahead and demonstrate some other features while we wait for Pat. We'll just do a little bounce back and forth here. So let's look at refrigeration. I'm in the OpenStudio application. I'm in the refrigeration screen, which is in the HVAC system screen. It's very simple to add a refrigeration system in OpenStudio. I just go to my library, and I go over here to the refrigeration system object, which is right here. 2 systems I can have. I need to have a drag and drop. And of course I can have many. I can have as many as I want. I can bring them in, delete them. Just if I have one, I want to go in and look inside that. I hit the arrow here, the magnifying glass, and now I have my drag and drop configuration where I would drop compressors. I would need to drop some sort of condenser. Here's an air-cooled condenser. And of course I need some sort of load. At minimum, I'll put a walk-in cooler here. And of course I can have as many walk-ins as I want, 2, 3, 4, so on and so forth. So you see the idea here. I've just drag and drop and created a system. Now I select any one of these items and I can edit the properties for them at the right here. So you'll see for compressors there are performance curves. The performance curves can be generated using compressor manufacturer software. For condensing, this is an air-cooled condenser. There's a performance curve for that again, heat rejection curve for that. If we look at the actual loads, we'll look at this walk-in as an example. There are data elements for that. Again, they map one-to-one to the Energy Plus object model for refrigeration objects. And then, again, if I click outside here, I'm just in the gray area for the system. I'm seeing the systems object. So what is this? Is this ammonia? Is this water? What is the refrigerant here? Where is this system? Where's the suction piping and so forth? These are systems. What's the temperature of the system? So these are the objects, again, that exist at the high level or the system level. Very easy, again, to create refrigeration objects and then run the simulation. So that would be refrigeration systems. Let me bounce over here into Pat. Now that we have our seed model loaded, I'm switching gears a bit. I'm going to load a couple measures that represent the AEDG measures. So I'll go here to the AEDG whole systems that are BCL measures, the HVAC whole systems. And you see a number of them here. I'd like to put, I don't know, let's put a radiant system in there. Sure. So that's a new measure group. And you'll notice when I put this in, my inputs are basically saying, oh, I've got some space types. Do you have any return air plenums? Nope, I've got none. And what's the cost, roughly? You know, this is a 6,000 square foot building converted to radiant. I don't know, 60 grand maybe. That's the only input I need for this. So let's put a couple more AEDG measures. We'll go to the envelope, for example, in terms of opaqueness. So we're going to put AEDG walls in there. Let's put AEDG roof in there. I'm really trying to get loads down. I'm going to put AEDG lighting in here, and then I'm going to run. So electric lighting, AEDG, and I don't know if I chose the K through 12 or not. I did. That's good. Okay. So you see here, now I want to make these actually separate groups, so I'm going to redo this a little bit. I'm going to make that a new measured group by itself. I'm going to make the envelope group because that lets me, we'll see here in the next step, AEDG walls, a new measured group, AEDG roof, a new measured group. Okay, so that's 4 measures, that's enough. We'll go to the next part in Pat where we'll select all, we'll run each of these measures individually, and then we'll create a package, essentially. So let me just call that package. Okay, and A good example of taking an old pre-1980 school and trying to see what would happen if we went deep with the AEDG guide. Next step, we'll just simply run the simulation. And this is going to take a while. I'm going to run this locally, so we're going to bounce back and look at the VRF implementation here. I want to make sure that these guys launched. I have a 4-processor laptop here, so I'm running 3 simulations in parallel. So it'll take 2 sets of runs to complete this. We'll come back and look at this in a few minutes. Let's go back over to the OpenStudio application, and let's go look at the implementation of VRF. So VRF is again under the HVAC system screen in the OpenStudio application, and it's very simple. It's very similar to what we just saw for refrigeration. We have some objects in our library, a VRF system object. Yep, and we can drop, just like with refrigeration, as many of these as we want into our model. So can be one, can be as many as we want. Let's go ahead and just keep it simple for today and look at one. Once again, just like refrigeration, we click on the magnifying glass and that would take us into the detail for a VRF system object. So now that we have a VRF system object, now we need to assign a terminal. That would just be simply a drag and drop. Place it in. Now you'll notice the terminal is asking for a thermal zone. So I go back to my model, my thermal zones, and oh, now I have a thermal zone connected to this. So what did I just create here? I created an outdoor unit, an indoor unit, and a thermal zone that's attached to that indoor unit. Okay, that's all good. Let's talk about how you configure the performance of this unit. So starting with the outdoor unit, you click on the outdoor unit and go to the edit section of the top right, and we'll see, let's see here, all of the properties again for the OpenStudio variable refrigerant flow outdoor unit. And looks like we're running some simulation stuff here. This laptop is running pretty hard, so hopefully that will come back to us. Yes, okay. So on the right here, you'll see a large list of properties that are needed to be entered for modeling this outdoor unit. And this, again, most of these properties are, if you look at them, they're curve fits. They're curve fits for things like cooling capacity as a function of the temperature boundary. These are, again, well described in that FSEC document. These curves are not just for cooling, they're also for heating. And there's some settings at the top of this that are very important. Those settings would be, for example, the rated heating and cooling, COPs, and so forth, the minimum temperatures. The point of this is do not run with the default values by any stretch of the imagination for this. You will not get any sort of reasonable answers. Settings here at the outdoor unit, again, are for where the master thermostats are set. And also right here, a very important one, is this combination unit, is it a heat pump unit or is it a heat recovery unit? And so if you do say it's a heat pump unit, a heat recovery unit, a number of curves become enabled that you need to define that would describe again empirically the performance of a heat pump combination indoor and outdoor unit. So that's all set again at the outdoor level. And then if we click on an individual indoor unit, there's another set of performance curves that one needs to configure. And I'll just show you again briefly what those are. I've clicked here on this indoor unit. I can have the name, and again, these could be hard-sized or auto-sized, but as you start to go down, you'll see the individual objects that form this zone equipment, the fan, and power curve for the fan, efficiency curve for the fan. Now we're into the the indoor unit curves for the DX coil, cooling coil inside this indoor unit. Again, well described in the FSEC document, and hopefully it will be much easier to model these VRF systems when those curves are available in the TPEX online database. So very easy. We can again go back into our library. We can create, just to make sure everybody follows this, we can create systems that have multiple indoor units with one outdoor unit. And of course, each of those indoor units would have to have a thermal zone attached to it. Very flexible, very easy to do that here using the OpenStudio interface. Let's just go back and check here and see where Pat is. Oh, we've got a failed run. Interesting. Let's see what happened there. Okay, we can deal with that. And let's see if the other runs make it through or not. Running. Okay, so we'll go back. We'll check on those in just a moment. Back over to the OpenStudio application because we're still running our Pat run. I think I've covered VRF in terms of how it's implemented here in the OpenStudio application. Just can't stress enough again that it's flexible, but it still requires a great deal of user-defined input in order to correctly characterize VRF systems. Let's go over to the supply and return plenums, and I'm going to delete this object here before I go there, and I'll go to my package rooftop air conditioner. This is my air loop. It's a nice simple school that we built a few moments ago. So in order to have a working plenum, I'd have to go back over here again into SketchUp, and I'd have to first again create the plenum. So it's not that hard to do. I'll just do that quickly. I'm going to select, for example, those spaces. I'm going to move them 3 feet in the Z direction. So they're sort of suspended in the air right now. And furthermore, I'm going to hide them so I can work a little bit easier on that plane. So I'm simply going to hide them. Now I'm going to create a new OpenStudio space here at the corner. Inside that space, I'm going to create a plate or a floor plate for that, and then I'm going to extrude that floor plate 3 feet in the Z direction. So I will select it, and I will extrude it 3 feet in the Z direction. And now if I go back here and at the highest level in OpenStudio and I unhide all of my objects, I see that now I have what could be either a supply plenum to the second floor or a return plenum to the first floor. So very easy to do so far, but always again, I need to make sure I match and intersect all of my surfaces so that now if I run a section through this model, through here, we can see if it was built correctly. So yes, those are inner zone surfaces. They're not outside walls. That was done correctly. So, okay, I have a plenum correctly characterized. Now I'd like to apply properties to that plenum. Let me, there we go. Turn off the section cut. And simply go into the OpenStudio application. I'll go into the inspector. And I'll go to the space types that I have in this model. And I'm looking for a particular space type here called the mechanical room, just as an example. There it is. I'm going to make a copy of it. And I'm going to call that my space type. Okay, so again, if I had time, I would set up a default construction set that would be applied to that plenum space type, just like we talked about. If not, it's going to inherit it. I'll just apply something to it randomly here for now. Now again, I need to go ahead and select that space using the OpenStudio tools. I'm going to make sure that that space gets called a plenum. And now we have just attributed the geometry. So that's pretty simple to create plenums. Now we would simply bring those into OpenStudio, the OpenStudio application here. And let's do that. Let's go ahead and we would we'll do that by simply launching OpenStudio. We'll launch another instance of OpenStudio, which will have our plenums here. And let's make that a return plenum for the first floor. So in just a moment, we should see OpenStudio pop up. There it is. It's got our weather file. We'll put a design day in there just to keep it honest for Chicago. And again, since I'm running simulations in parallel here, it's really taking resources from this machine, so I'm not sure if you guys are seeing what I'm doing here. I hope you are. Good. Okay. So now if I go here and I look at what thermal zones are in my model, I'll see that there's only one thermal zone. I need to make a new thermal zone, and I need to call that the plenum zone. And now I need to go into my facilities tab here and look at my thermal zones and say, oh, yep, there's my space that needs to be applied to the plenum zone. So okay, now I've applied that space type to a thermal zone, a plenum zone. And now if I go to my HVAC configuration screen here, you'll recall the same air loop we looked at just a moment ago. If I click on the zone here, I have a new icon up here on the left. That's where I again would select plenums I want this to be a return plenum. And so, you know what, I'll have a new return plenum, and it's my plenum zone. And there it is. So I've just linked the geometry, and it's a little bit of a hack here because this system serves both, that zone serves first and second floor. It's not totally correct. But you can see how one would wire together a building model that had a return or a supply plenum area, plenum space type, if you will. It was combined to create an unconditioned thermal zone over the OpenStudio application. You would then go over and just link that using the HVAC system screen, configuring it as the plenum zone type. So I can quickly over here, just to demonstrate this, I'll just create a couple junk zones here. They won't really have any meaning, but I'll go back into the HVAC system screen now. And if I click on this, I could, again, go back and create a new supply plenum. You'll see the zones I just created are available. So very easy. I, of course, would have to connect geometry to these in order for them to be proper. But that's how one creates supply and return thermal zones, unconditioned thermal zones in Energy Plus. Now, those thermal zones, just to talk about it again, they're essentially mixing objects. They're places where many streams come together, and thermodynamically the air and the energy, mass and heat balance occurs, and it mixes before it goes back to your air system. All right, let's see what we got here. Well, we got a couple failed runs here in PAT. I'm moving back over to PAT, and I expected, since this radiant failed, that the package was going to fail because it had that in it. And that's not, I might have to do some digging to figure out why did that fail. I do, in PAT, those of you who have used it before, it gives us fairly verbose information for why. It looks like I have some kind of mechanical ventilation controller issue, and I'd have to go back and debug my model to make sure that this is properly specified. I'm not going to do this now because we only have 8 minutes left in this webinar. I'm going to go through and just show what we have here, which is the summary of our PAT run. Assuming that the runs that didn't fail, I'm seeing the ones that actually did run, and I'm seeing their savings. That's pretty interesting. There's not much. So for whatever reason, these measures did not save a whole lot of energy over my constructions that were put into my baseline building. I've got a little bit of gas savings with the roof, very little bit of gas savings, not showing any electric savings. Very strange. Well, that's okay. The most important thing about this feature is that I can select any one of these alternatives, and I open the file in the OpenStudio application. And this is important to understand, because when I'm doing that, what I'm actually doing is I'm exporting this particular design alternative, and it becomes a new seed building, a new seed model. So you'll notice here I opened up a new instance of the OpenStudio application, and I don't have measures attached to it. There are no measures here. That measure was incorporated into this base model. So if I look at, for example, let's see, which one did I do? I took the interior lighting alternative. If I go back to that model and I look at the interior lighting objects, they come from the interior lighting objects that are in my model. They come from that measure. Okay, so that's exactly how they were populated. So there's a workflow here. If you're paying attention and if you're following me, there's a workflow for creating a new OpenStudio base model here by leveraging these AEDG measures. And it's a powerful workflow. It's actually really powerful. Can be. It can really make better, faster, cheaper modeling if you consider all the time it will take to do this in most conventional tools. So I'm going to go back to our slides here. We've got about 5 minutes left in our webinar. I want to talk a little bit about OpenStudio's development, because essentially today or tomorrow we should be seeing the release for OpenStudio 1.3.3, and that would be we call the minor releases that are essentially out every 2 weeks. Suffice it to say there's a very committed path for development of OpenStudio. There are minor releases approximately every 2 weeks, major releases approximately every 3 months. And those releases incorporate features that are described on the roadmap here, the roadmap document that you can see. If we look ahead a little bit at what's coming, we're in, again, OpenStudio version 1.3.2 moved to Energy Plus 8.1. We should have 1.3.3, again using Energy Plus 8.1 any day now. At some point we're going to transition to Energy Plus 9.0, which is a major deal. A major deal, and for those who aren't aware of that, that's what that means is we're moving the old code, the old Fortran F90 code, into modern C++ object-oriented code for Energy Plus. Lots of things are going to change on the Energy Plus side here, and frankly, if we're an OpenStudio user, we don't care because OpenStudio is going to manage that transition for us. Our ability to take in and export an IDF or an IDD or IDXML or whatever it ends up being called at this Energy Plus 9.0 level is going to be really invisible to us as an OpenStudio user. So that's an important point again for OpenStudio Energy Plus integration. The next slide, again, I'm showing the OpenStudio roadmap. I just looked at this morning. I copied some of the bullets that are on the public-facing roadmap. You'll see here again what's planned for version 1.4 will probably be late June release, and then 1.5, which will be a late September release. I want to point out that at the bottom of this roadmap there are links to 2 public-facing Google Docs spreadsheets that once you log into a Google account you can contribute to. So you can actually ask for and see the roadmap in much more detail than just these bullets that are there. There's a tab in the spreadsheet that again asks for feature request. You put your name down, you describe what the feature is and so forth, and the team reviews these, and it does get included in the roadmap planning. I'll close down with a couple more slides here at the end. The first one would be to say we'll repeat this webinar, Performance Systems Development. We're repeating them on every major release. So we expect to do one again for version 1.4 sometime in July. We are a licensed partner with NREL for supporting OpenStudio in terms of training, consulting, and support services. And we do have a website called openstudiotraining.com where you can sign up for that webinar, probably where you signed up for this one. You should be watching out for that again in June to find out what's new with OpenStudio version 1.4. The next step for those of you who are on the webinar, I would suggest that you go ahead and download, if you haven't already, SketchUp 8.0, download and install Energy Plus, either Energy Plus 8.0 or Energy Plus 8.1. Download and install OpenStudio version 1.3 or version 1.3.2. Again, those are linked to Energy Plus 8.0 or 8.1. Create an account, a free account on the NREL BCL, and download the measures, the AEDG measures and so forth, and just start experimenting. Experimenting with workflows, take what you're doing now, see if you can find a way to do it faster, cheaper, or better. There's a lot of websites where you can go for help. A good one is there's a YouTube channel with probably about 70 different short clips of OpenStudio videos, user videos. There's also an OpenStudio support forum that NREL hosts where you can post questions that you have. And again, the next free OpenStudio webinar will be sometime in July after the OpenStudio 1.4 release. But we'll do something similar to this and we'll cover the new features in OpenStudio 1.4. The last slide I have here again is for those of you who want to go a little bit deeper and need a little bit more support than what you're getting from the free resources. We at PSD do offer OpenStudio training. It's open market training. Our next training class is scheduled for June 17th here in Syracuse, New York. It's a 2-day OpenStudio user-facing training course. We have classes scheduled in September and October in New York State as well. If you're a New York State resident, these training courses are heavily subsidized through a NYSERDA training pond. If you're not, you're still available to attend. You're still eligible to attend. You can again look at openstudiotraining.com for more information and registration for those courses. We are also going to present a measure articulation or a measure authoring course at the ASHRAE EBIPSA SimBuild conference in September in Atlanta. So keep your eye out for that. There's plenty of opportunities again if you're interested in learning more about component development, measure development, API assistance, general OpenStudio consulting. We at PSD are again firm believers that there are ways to make modeling better, faster, cheaper, leveraging all of these tools and the SDK that is underlying them. So I'll leave you with this final slide. I'll thank you for your time today. I think we covered everything we intended to. Please watch the website for the next webinar on version 1.4, and we will be recording this webinar and we'll post it up on our website. I apologize for not having time to look through the questions. If there are key questions I see that I want to answer, I'll try to post some answers to the website as well, but I can't guarantee how many I'm going to be able to get to. So thank you, everybody, and enjoy the rest of your day, enjoy your week, and we'll be in touch soon. Take care.